Welcome to WASA Distance Education. This is MBF3C, Grade 11 College Prep Math. I'm Pete, and I'm your teacher. So, good afternoon. We're just getting towards the end of our second week here, and we're actually getting towards the end of our first unit, which actually makes exact sense for our schedule. So, yesterday we started looking at the exponent laws, and I'm going to talk about them again today. But first, I'm just going to spend a couple of minutes to kind of talk about how to calculate exponents on your calculator, just in case you need some review there. Now, this is important for the exponent laws lesson, but it's also going to be important for our next unit. Where we're looking at interest rates and things like that. You'll also be using exponents quite a bit. Okay, so we'll get started there. I see Alex, so welcome, Alex, on the broadcast. So, okay, here. Sorry, I just got a little record keeping to do. Okay. So I'm just going to make a blank page here. We're basically looking at lesson 4 of unit 1, but I just want to talk about powers and how we calculate them on our calculator. So let's say that I have a power here. We'll call it 5 to the power 2. Okay, we call that 5 squared. We have special names for the ones that are with a 2, an exponent 2, we call it squared. And for an exponent 3, we call that cubed. Those are just our special names for those particular powers. It's not really a mistake to say 5 to the power 2, and I think you'll hear me kind of slipping back and forth between the two ways of saying it. Okay, for all the other ones, you'll just say whatever the number that's the base to the power of, or to the power, whatever the exponent is. Okay, without saying of. Now, if you want to calculate this, you're going to look at your scientific calculator, and every scientific calculator is going to have this function on it, but it's shown in different ways. Now, let's talk about how you know you have a scientific calculator. You have a scientific calculator if it has these buttons on it. Okay, and we're going to be using those actually in Unit 3 quite a bit. But that's how you tell you have a scientific calculator, because they all have those buttons, sine, cosine, tan. Now, so this is just how you know that it's scientific calculator. A scientific. Now, if you have an iPhone, okay, and this is probably some of the other smartphones as well, but I know for sure on a smartphone, if you have a smartphone and you bring up your calculator app, and with the latest iOS, it's I think you swipe from the bottom, even on the lock screen, and you have the calculator icon. Well, if you bring it up and then you turn your calculator sideways, it actually gives you a scientific calculator. It turns into a scientific calculator. So just if you don't happen to have a scientific calculator, that's something that you can always use, okay, is your smartphone. And if you need a scientific calculator and you're part of this course, just let me know, and I can actually send you one up on the Express, and you'll have it within a matter of days, I guess. Okay. So you have your scientific calculator, and now you want to calculate an exponent, say 5 to the power 2. We know that that's 5 times 5, so that we can work that out fairly simple, but what about 5 to the power 3? What about 5 to the power 8? Okay, that gets a little more complicated. And there's it's if you want to multiply 5 by itself 8 times, that's fine, but then, what if you make a mistake? What if you only multiply it 7 times? What if you multiply it 9 times? Right? It's better just to use the built-in function in the calculator. So there's 2 ways that you'll see this written, actually 3 ways that you'll see it written. On a lot of calculators, it's going to be x to the y. It'll just be a button, x to the y. Sometimes it's y to the x. On Texas Instruments calculators and some others, it's an up arrow. Okay, there you go. That's the button that you use. Okay, so to use this, then you would just basically, to use it, pretty much any of these, to calculate, say, 5 to the power 8, you'd type the 5 button, then you'd go x to the power y, or whichever button you have on your calculator. Then you would press the exponent. Might be 2 decimal places. You might have to use your plus minus button to make it negative. And then usually you press equals. Okay. So go ahead and try that on your calculator. And I'll actually tell you what that number is right here so you can know that you got it right. 390,625. Okay, so there you go. So that's what it is. And then you can calculate powers from here on out, right? You know that 5 to the power 2, that's going to be equal to 25, and that's should be 125. 5 to the power 3, we'll double check that. Okay. So now you know how to calculate powers. Now, if you're having trouble with your calculator, they're all different, right? So if we were in class, what I would be doing right now is going around and making sure everyone knows how to do this. So if you can't quite work out your calculator, you can send me a note. Send me a photo of the front of your calculator. That's the number one, right? Text me a photo to my cell phone number. Let's see here. 738-1879. That's area code. What's our area code? 807. Okay, so that's that. You can text me a photo of the front of your calculator, or just send me a little note with the model of your calculator, wherever it says on any words that it has on the front of it, and I'll do my best to explain how to use that calculator to you. Okay, because it's really important that you're able to do this comfortably. Okay, great. So so that's our first little bit of this lesson 4. And you're going to be using it quite a bit, this power, in this unit, and then in Unit 3, you'll be using powers quite a bit, and even maybe a little bit when we get to trigonometry in Unit 3. Okay. So let's move on here, and we were on Lesson 4, and we were looking at the exponent laws. And the exponent laws just make it easier. Very often when we have a, oops, I think I'm not quite far enough along here. Very often when we're manipulating algebraic expressions, we end up multiplying things together, and we end up with quite a number of exponents. And so this just gives us a simple way of reducing them, of simplifying them, and making it a little easier on us to do these calculations. Okay. So we looked at, there's actually 3 main laws and then a couple of kind of special cases. We looked at the first couple yesterday, but let's just back up a little bit, no problem there. So we're on page 26 of Unit 1, and we're looking at law number 1, multiplying powers. Okay. Now, when we talk about the base, of course, we have the number, right? And then we have the exponent. So I've written the number 5 in blue. In this case, that's the base. Okay. And then the exponent, okay, is the number that up above. Okay, the power, basically. We would read this 5 to the power 3, except that the 3 is a special case that we call cubed, right? 5 to the power 3 would be just 5 cubed. Okay, either way is correct. Now, when we're multiplying powers, or when we're using in the first 3 laws, it's important to understand that we can only apply these laws if the bases are the same. Okay. Now the base can be a constant like that, so 5, or it can be a variable like x. Okay. And we can apply those laws in either case. Okay. So we took a look at the examples, and we found out that when we multiply powers together, what we do is just add the exponents. Okay, and the way they show it is actually pretty good in the text here. So for example, looking at example 1a, we get 5 to the power 3 times 5 to the power 7, and that's going to be 5 to the power 3 plus 7. Okay, and then we just add those together, and it's 10. Now the way they wrote it isn't too bad. I might be inclined to write it 5 to the power 3 plus 7 in brackets, just to make it clear what we're doing. Okay, so let's see. I see we have a call from Wiagamo. Is that Charlotte? Okay. Is there someone from Wiagamo? No? Okay. Okay. Oh, we got someone from Wiagamo.
Hi.
Hi, how's it going?
Good.
Okay, great. So, all right, so we're on we're at page 21? No. Unit 1, page 26. So we're looking at multiplying powers, the power laws. Now, were you able to listen in a little earlier, Charlotte?
I'm at Wasa right now.
Oh, okay. So are you able to, you're at WASA, are you able to look at the screen then?
I gotta log in first.
Okay, great. So you can do that. So I showed just a little earlier about how to calculate powers on your calculator. Are you okay with that, Charlotte? Do you want me to go back over that? Okay.
What?
Oh, a little earlier I showed how to calculate powers using your calculator.
I haven't seen it yet. I think I remember how to do that.
Okay. All right. Well, you can try a few of those, and then we'll. If you have any difficulty at all, I can go back over that. Or you can watch the tape, I guess. The tape? The recording? Okay. So we're just reviewing from yesterday law number 1, multiplying powers, where we just, if we have the same base, then we just add the exponents together. Now, when we say add the exponents, if one of them is negative, then we'll just, it's like adding signed numbers together. Okay, so we'll treat them that way. Okay, so in this case we had 5 to the power 10, and that's really all you have to do. When they tell you to simplify a power, that's all they're looking for. And the reason for that is that, if I'm calculating something, chances are that's all I need, 5 to the power 10. If I expanded that, it's going to be some big ugly number. But just for the sake of you practicing calculating powers, go ahead and try 5 to the power 10 on your calculator, and see if you get this number right here. Let's see, 9, 6, 2, 5, and then I'm going to group them together. Okay, there you go. Something like that. 9,765,625,625. That's what I got anyway. So make sure you're able to do that on your calculator, because you're absolutely going to need that this unit, but also when we get to the next unit. Okay, you'll be calculating powers pretty much everywhere you go. So that was the first example. Now the second example shows where the base is negative, and I like the way they do their notation. They put the entire number, including the negative sign, in brackets, and then they put the exponent in the normal place. Okay, and that kind of helps you figure out that the negative sign is part of the is the base. Okay? And that's especially important when your exponents are even. If your exponents are odd, then it's a mistake, but it wouldn't actually change the value. Because you take a power of an odd number, the number's still going to be, or sorry, you take the power, an odd power of a negative number, the answer is going to be negative, and whether you had that a negative sign in the bracket or not wouldn't matter. But it does when things are, when the exponent's positive. When the exponent's even. Okay, I'm going to stop talking now. So for example 1b, one of the sort of the tricky parts is that second negative 3, didn't have an exponent at all. So remember, if there's no exponent there, it means that it's to the power 1. Okay, we just don't go around writing things to the power 1, because every number that doesn't have an exponent is considered to be to the power 1. That may seem odd until you actually try it on your calculator. If you try taking any number to the power 1, you'll find out that it's the number. So in other words, finding the power 5 to the power 1 is 5. The same as 5 times 1 is 5. 5 divided by 1 is 5. You see, so that's why we don't bother showing the ones there. It doesn't change the number. We'll only show it when it's necessary. So for the case of b, then, we do the same thing. We apply the law. We add the exponents together. So it's going to be negative 3 to the power 2 plus 1. And again, if you want to put the exponent calculation in brackets as well, you're welcome to do that. Okay, and it clarifies things tremendously. Okay. Now, when I was talking about writing powers and exponents, the model I use is kind of like the exponent is like the peak of a baseball cap on the number's head. It has to be up high enough that it's clear that it's not a 2-digit number you're writing, and it has to be big enough to be read, but about half the size of the base. Okay, so if your writing tends to be kind of small, then you might make the exponent a little bigger than half, but that's what we're looking for. Because if you're writing along, it's very easy to kind of start writing your exponents a little too big and a little too low, and then they start looking like 2-digit numbers instead. Okay. Now the last example that they showed here was C, and what you have there are two variables, and the variable is x, so it is the same base, no problem there, and we have x to the negative 3 times x to the 11, and we handle that exactly the same way that we handle the other ones. They put the in the example, they put the exponent negative 3 in brackets just to make it clear what's going on, and it's perfectly fine. Brackets are kind of like the highlighter of mathematics. We use them to kind of set stuff aside, to make order of operations clear and stuff like that. Okay. If you remember back in elementary school and they taught you BEDMAS and PEDMAS and all the order of operations, I read a great essay by a mathematician that he said that that stuff is all not needed. It's all nonsense, and that actually mathematicians just use brackets to make order of operations clear. And he was actually right. Anyway, so feel free to use lots of brackets if you want to make stuff clear in your math. So for example 1c, then we ended up, so we have negative 3 plus 11, right? So we're going to you calculate that on your calculator, so you get 8. You should try doing that from time to time, because some calculators, to enter a negative number, sometimes you have to enter the number, and then there's a button called plus minus, and you have to press it. At some calculators, if you try to use the minus sign to make a number negative, some calculators don't like that. They kind of will make an error, or they won't recognize it or something. So make sure you're able to enter signed numbers and do a little calculation like negative 3 plus 11 and get the correct answer. okay? Because you're going to be using quite a few negative numbers in the next unit as well. All right, so that was our first example of one of the three laws of exponents. So when the bases are the same and we're multiplying variables or constants, then we just add the exponents. Pretty straightforward. Now for law number 2, it's really the inverse of that. Okay, when we're dividing variables or constants with the same base, we subtract the exponents. Okay, so they're giving us the example, and doing it in fraction notation, but it would be just as valid if it was 12 to the power 5 divided by 12 to the power 3. That's exactly the same thing. So for example 2a, we have 12 to the power 5 divided by 12 to the power 3. We're just going to subtract them. So they show down here, it's just 5 minus 3, and we end up with 12 squared, or 12 to the power 2. Now you can work that out in your calculator. It's 144, right? And there's nothing to stop you from working out 12 to the power 5 on your calculator, right? So 12 to the power 5 is some big, ugly number. And then really that's the issue, right? The idea is the model I use when I'm dividing exponents like this is I actually cancel out. If we take a look at example 2a, and I have an exponent 3 down here, I'll cancel out the 3 and then cancel out 3 of the exponents on the top. Okay. Now they don't show to do it that way on the in the text, but that's the model I use when I'm canceling out exponents. Okay, and it ends up to be the same thing. Now the reason I can do that is, I'm going to make a new page here. The reason I can get away with doing that is, sorry. Okay, that would have gone a little smoother if I'd actually had the page available here. So if I have 12 to the power 5, what that really is 12 times 12 times 12 times 12 times 12. I have 5 of them there. And 12 to the power 3 in the denominator is just equal to 12 times 12 times 12. Whoa, okay, that was an ugly looking 12. So really, if you had this situation here, I'll draw my line here. If you had this situation on the right hand side where you had 12 multiplied by itself 5 times and 12 multiplied by itself 3 times in the denominator, the rules of mathematics allow you to say, all right, well, I'm going to cancel out those 12s, right? And I'm going to cancel out this set of 12s, and I'm going to cancel out this set of 12s, right? So if I then simplify this, I have 12 times 12 in the numerator, and I have 1 in the denominator. Yeah, 12 to the power 2. Okay, so that's where we get to law number 2. So if you're not really sure, if you forget it a little bit, you can just think back to this, where it's just the expansion of a base with an exponent is just the base times itself, the number of times in the exponent. And the reason we subtract the exponents is that we're basically canceling. We're using the subtraction to cancel out the exponents. Okay, I hope that that's a little more explanation than they give in the text. So I hope that helped rather than hindered. Okay. Now I guess this would be a good time to mention, if because we have a sort of a non-traditional classroom, I'm sort of presenting this. If I cover something and you just don't get it, that's not your fault. It's my fault. Okay? And it's my job to make sure you get it. So, don't hesitate to contact me after the class. You could try to watch the recording again from the archive on the WASA website or from YouTube, right? You can watch the recording again, right? Or you could reread the material. But if you're really having trouble with a concept that I've covered, I encourage you to contact me. You know, email, you have my cell phone number, right? You can Facebook, PW space WASA. Okay, and because I want you to understand stuff. Okay, so if I, if I explain something that's just not quite gelling, make sure you contact me as soon as possible too, because otherwise, you try to do the key questions, and it just kind of makes it difficult for you. Okay, so that's the thing. Now, let's take a look at our second example here, example 2b, dividing power. So we have y to the 15 divided by y to the 14. So again, we can write y to the 15 minus y to the 14 as the exponents, and then we end up with y to the power 1, which you can either leave it like that or just write it as y, because we don't have to show an exponent to the power 1. Now, if you did it the way I showed you a little earlier, then you'd just be going, well, that's 14, that becomes a 1, and then that just becomes a 1. That becomes a 14 becomes a 0, and that becomes a 1. Y to the power 0, we're actually going to cover that. You know what? This was a bad example. We're going to cover that as one of our two special cases, an exponent to the power to a base to the power 0. So let's take a look at example C here, and they're giving us a little bit of a challenge because they're giving us negative numbers, and they've written it in this division notation. So if we were writing it in the way that they've shown for the first two examples, it would just be a negative 6 to the power 9 divided by negative 6 to the power negative 4. Now, don't let these sign numbers throw you. You're still subtracting, and you're going to have to do the subtraction as if they are just signed numbers. So the way they're showing the answer here, it's 9 minus, and then in brackets, negative 4, which is pretty much the only way to write that. If you have a subtraction with a negative number, you're going to have to put the negative number in brackets. Okay. Now, what I was showing yesterday, and I'm just going to go over that again because it's kind of an important concept. We talked about back in here, I'm going to make a blank page here. Back when we were looking at algebra, we talked about what happens if we have something like this, right? We have a negative sign in front of an x plus 1, a binomial. And what we figured out was that we could change that, what that subtraction really means, or the negative sign really means, it's not subtraction, it's negative 1 times whatever's in brackets using the distributive property. So what this really comes out to, it's negative 1 times x, which is negative x, and then negative 1 times negative 1, which is negative 1. And in effect, what the negative sign does is it flips around the sign of everything in the brackets, if it's just negative 1. Okay? So when we have something like negative 6, and then we're being asked to evaluate 9 minus negative 4, we have a very similar case here. So I want to just go off to the side here and show you how this works out. We have 9 minus, and then negative 4. So remember that this negative sign sitting in front of the bracket really means negative 1 times what's in the brackets. So let's rewrite this then. We have 9. Now, what's negative 1 times negative 4? Well, the signs are the same, so the answer is going to be positive, and 1 times 4 is 4. And you see what we've done is we've eliminated the negative sign, and we've gotten rid of the brackets all at the same time. So now we can rewrite our power as 9 plus 4, which equals, oh, okay, I don't know where that came from. Negative 6, 9 plus 4 should be 13. Okay. So that's how we got to 13. Now, if you try that on your calculator, 9 minus negative 4, that would be very helpful if you're able to do that. And very often you would type the 9 on your calculator, you type the negative sign, and then most calculators will require you, there's one of two ways to do it. Usually they require you to type the 4 and then press a plus minus button, okay, to make it negative. Well, that's sometimes we forget to do that, and maybe it's kind of an awkward notation. So it is important to be used to doing it. On other calculators, there's another button, and it's a negative sign in bracket button. Okay, and you can press it before a negative number. So it's a more conventional way of entering things, but this negative sign in brackets is not the same as the minus button. Okay, it's kind of unfortunate that we're using just our mathematical notation has evolved to use a minus sign to indicate a subtraction operation, and then the same symbol to indicate that a number is negative. It'd be nice if there were different symbols. Okay. All right, so let's go back to that page, which should be page 26. So we were working on example 2C. So we see we have negative 6 to the power 13. Okay. Now, if you wanted to evaluate that, that question's done as far as it's saying simplify. But just for our interest here, you could try evaluating that. I'll tell you what I get on my calculator, and you can try it on yours and see what you got. So negative 6 to the power negative 13. I got a very interesting thing. I get scientific notation. So I have negative 1.3006. Well, I'll call it 1. And it says e to the 10. Okay, scientific notation. It's a very big number. Okay. So you can try that on your calculator. See if you get something similar. It may vary in these digits here. I rounded a little bit. Okay. Now, the other thing we get, which may seem a little bit strange, is we get a power to a power. And what this really means is, and it happens a bit. Let's say we have 5 to the power 2, and then for some reason we plug that into an equation where we're asked to find the cube of that, right? So we end up with 5, a power to a power is what it's called. Okay, so that's a very different situation than, say, 5 to the power 2 times 5 to the power 3. Okay, that's a different case that we're dealing with. In this case, what this expands to be is 5 to the power 2 times 5 to the power 2 times 5 to the power 2. Okay. And now we can use our law number 1, which says that when we're multiplying exponents with the same base, we actually add them all together. The exponents. 5 to the power 6. That's what we end up with. Okay. Well, let's take a look at this 6 here. The reason we ended up with 6 is that we multiplied basically the squares, these ones, inside the bracket by the exponent, the outer exponent. Okay, so that's where we get the power to a power law. What it says is that when we take the power of a power, we multiply the variables together. So let's go take a look at an example. Okay. So we have a power to a power, then we're going to multiply those exponents together. So for example, 6 to the power 4, and that's to the power 7, and that's going to be equal to the 6 to the power 4 times 7, which equals 6 to the power 28. That's a big number. Okay. Well, let's take a look at part B here. We have negative 2 to the power 5. Which is then to the power 4, so the simplification of that is negative 2 to the power 5 times 4, which should be, let's see, should be 20. Okay, so we're just multiplying the two exponents together. Now this is only in the case where we have something that's a power, and then we have another power outside of that. Now, in the case of s, and this will happen quite a bit. Okay, s squared comes up quite a bit in squares, and so we have s squared, and then that whole thing is squared. So that's going to be s. I'm just going to undo that. I'm just going to make a small s. It's kind of ugly, but oops. Okay. 2 times 2. Okay. I'm going to have to just 4. Okay, I didn't write very clearly there. Let me see if I can. I'm just going to it's 2 times 2. There you go. Better. Okay. So that was it. That's power to the power. And you can actually try that out on your calculator. Now the problem is that once we get fairly large exponents, your calculator will very often say tilt. It'll give you some error if you try and take the power of a very big number. Okay. Okay. I'll find it. Now, okay, and those are the solutions on the top, page 27 for the the 3 examples I just did, and I showed them to you on the previous page. Okay. Now, there's just 2 special cases that we can deal with, and then that's it. We're really done looking at the power laws. Okay. All right, and I see Ant is there up in Sagiko. How's it going, Anthony? Well, I guess you can't really answer, so we'll just say hi. Okay. Oh, hi. Okay. You able to follow along?
Yeah.
Okay. Great. Okay. Well, I can hear you. That's perfect. All right. Glad to see everyone on here. Now, if you missed something, if you missed the start a little bit, or if for some reason, if you'd like to see part of it again, you can go to the WASA archive. You go to the WASA website, and then go to the archive. The instructions to do that are at the back of the study guide. Okay, so you just follow those instructions. What you basically end up doing is downloading the file, and then you can watch this on your computer. The other way to do it is to go to my YouTube page, PW space WASA, and then you just search for 2A MBF3C, and you'll find all of the classes. Okay, and just look for the class that you're interested in. Okay, now the difference between going to the archive, in the archive you download the whole file and then you watch it, which may work better for your internet connection. And then plus, once you have it, you can watch it again without downloading it. The thing about doing it on YouTube is it streams it, so it'll reduce the quality a little bit until it matches the amount of internet you have available. So try it both ways and see which one works out better for you. Okay. Okay. So now we're on page 27 here, and we're just going to talk about the 2 exceptions, or 2 special cases, not exceptions. Now, anything with an exponent of 0 equals 1 with one exception. Something with a base of 0, it's just undefined. It's kind of like dividing by 0. Okay, so that's just undefined. Okay, otherwise, anything with a exponent of 0 is just equal to 1. Doesn't matter what it is. Okay, and that's really, I can't really say much more than that. 1,000,000 to the power 0 is 1. But that's it. Okay, x to the power 0 is 1. Okay, so sometimes that can be very helpful in sort of working through algebra problems. Okay. So that's it. Now, for example 5, they're talking about negative exponents. So anything, okay, I don't know if I really like this. I don't know if I like this explanation gets flipped, but that we'll take it. Okay. Basically, what they're saying is that a if an exponent has a negative sign, then you can make it positive by taking the reciprocal. Now, the reciprocal, if you have a calculator, a scientific calculator, you should have a button on there somewhere called 1 over x. It might be in the shifted functions or something. And that is, of course, on my calculator, Texas Instruments has to do it differently. It's x to the negative 1. But what that means is it just takes a number and divides it into 1. In the case of a negative exponent, if we rewrite it as a division by 1, this changes the sign of the exponent. Okay? And then, of course, we're going to simplify that further, 1 over 2. Okay? And that's all it is. It's really just a pretty straightforward rule, but it really helps us in some cases. Okay. So in this case, for example 5b, 4 to the negative 3, we can write it for the 1 over 4 to the positive 3. Okay. And when they're talking about simplifying here, they're talking about rewriting the expression with a positive exponent. That's really what they're talking about. Now, it's interesting that this, if we look at example 5c, this rule actually works even when the base and the exponent are in the denominator. If we take the reciprocal of 1 over 3 to the negative 6, it's going to be 3 to the positive 6 over 1, which is just 3 to the 6. Okay. So it'll help us get rid of a negative sign in the exponent. Now, question D, question D is kind of, you see that what they did was they took the reciprocal of the two numbers inside the brackets. And that's, if you want to think about it that way, that's fine, right? If you want to get rid of the negative sign on the exponent, just flip the numbers in brackets and change the sign. If you want a more thorough more thorough explanation, then I will give that to you right now. All right, let's go to a new page. So the question, and this is example 5, example 5C, and no, example 5D. Okay, so it's 3 over 4 to the power negative 2. Now what this really means is 3 to the negative 2 over 4 to the negative 2. Okay, that's what that means. Okay. And in fact, we can write this as 3 to the negative 2 times 1 over 4 to the negative 2. Okay, and actually that could be 3 over 1. Okay, it doesn't, every number we write can be over 1, and that's, wow, I just made a mess of that. All right, 3. All right, 3 to the power negative 2 over 1. Okay, and the reason we can write it this way, if you remember, if we're multiplying fractions, 5 times 1, even 1 times 2 over here, if we're multiplying fractions, all we do is we just multiply across. This would be 5. 5 times 1 is 5, and then 1 times 2 is 2. Okay, so that's why this works. Okay, so having factored it into 2 separate fractions, now we can apply that rule that they talked about, which is that if we take the reciprocal of each one of these, we can change the sign. So if I take the reciprocal of the first one, we have 1 over 3 to the plus 2. And if I take the reciprocal of the second one, I have 4 to the positive 2. And it's over 1, though, we wouldn't normally write it that way. But now, if I multiply it back, what we have is 4 to the power 2 over 3 to the power 2, and which is 4 over 3 to the power 2. which is what the answer that they got. Okay, which means that you can think about it, if this helps you to understand what's going on, think about it that way. Otherwise, the way they show it in the text is simply that if we have 3 over 4 to the power negative 2, if we write 4 over 3, then we're allowed to write positive 2. Okay, so that's the way they presented it in the text. What I just showed you is kind of why we're allowed to do that. Okay. Well, that's great. The thing is that the text then, after showing us all these really softball examples, then gives us something like example 6a. Yipes. Okay. But actually, it's really not so bad. So let's take a look at this, and you'll have a solution. I'm just going to make a new page here and just solve it kind of separately. Okay. So this is example 6, and that's on page 27. So this is example 6a. And so it's n to the power 4 times n to the power negative 5 divided by n to the power 6. Now notice that they've done something which is kind of dodgy here. He put a multiplication sign in an algebraic expression. I've been telling you up till now that we don't do that. So I'm not really sure why they did that. But anyway, if you wanted to write it just with brackets around the end of the 4 and the n to the power negative 5, you could do it that way as well. Anyway, the rules still apply. So let's work it out one step at a time. The first rule we'll apply is the rule where the bases are the same, so the n, and we're multiplying exponents. What we do then is we add them together. So 4 plus negative 5. Okay. So that's the numerator, and let's just copy the n to the power 6 over. We don't have to worry about that right now. Okay. Well, let's simplify. So 4 minus 5 is what we're really saying. So 4 minus 5 is it's n to the negative 1, n to the negative 1 over n to the power 6. Okay. Now, there's a couple ways we could work this out. We could take the inverse of the numerator, make it 1 over n to the 1, but it's probably just as easy to apply the second law, the exponent law for dividing, right? And that is that if we have an exponent with the same base, a power with the same base, then we can subtract them. Okay. So we have negative 1 minus 6 is should be n to the negative 7. Now remember what they said on the previous page. They said that solving it, no, I think it's actually on the same page, that when they say simplify, they intend for you to write it as a positive exponent. So in order to satisfy that requirement, we do have to take the reciprocal right there. Okay. Now if you answered this on an assignment, I think yeah, I'd accept that. Okay. It should really be this. What I would probably do there is just write the way it's supposed to be. They're both pretty compact notation. Okay, so it seems like quite a few steps, but if you just take it one step at a time, and what I suggest you do is try to apply the law number 1, the multiplying exponents, and then law number 2, and then look for any special cases as you're going along. Okay. All right, well let's take a look at a little trickier one. And I'm going to just extend this page. So on page 27, example 6b. Wow. Okay, this looks pretty. So 2 to the power 4 times a to the power 2 times 4. Oh, wait. Sorry. I was looking at the wrong spot. Sorry about that. All right, let's try this again. 2 to the power a squared, okay, to the power 4 times 3 to the power 3 a to the power 4 times 2. Wow. Okay, well, again, they're using a bit of non-standard notation there, and but we know what that is. If you wanted to eliminate that and just write it, it would be 2a squared times 3 times a to the power 4 squared. That's how it would actually look. Um, yeah, so you could always do it that way. Okay. Well, all right. So let's see what we can do. Probably the easiest now is to take care of the power to the power situation. So this 2a to the power 2 to the power 4. Okay. Now, also keep in mind that we have to kind of, if there's a constant there, we're also going to have to deal with the constant as well. Okay. So we can rewrite this first expression then as 2 to the power 1 times 4 times a to the power 2 times 4. I hope my writing's clear enough there. Okay, so that's the first one. Then we have 3, and now we have a to the power 4 times 2. Whoops. Okay. Yeah, I'm just going to extend the page right here. Okay. So let's work this out. I have 2 to the power 1 times 4, which is 2 to the power 4. And then I have a times 2 times 4, which is a to the power 8. Okay, so that's the first expression. Then we have a 3. And then I have a to the power 4 times 2, which is 8. And that is an a, not a 9. Gotta watch myself there. Okay. Okay, well, something interesting has happened, because you see that we now have a to the power 8 and a to the power 8. So this gives us an opportunity then to apply these power laws again. When we're multiplying things together like this, there's no problem in a case like this. This 2 to the power 4 is being multiplied by the whole expression, right? So let's put all the constants out front. So 2 to the power 4 is just 2 times 2 times 2 times 2. We can work it out on a calculator, but it's basically 16 times 3. So I put the constants out front, and then we have a to the power 8 times a to the power 8. So I didn't really change anything. I just expanded the 2 to the power 4. And that's just so that I can then work out a number here. So I ended up with 3 times 6, 18, 40, is it 48? Yeah. So it's going to be 48. So I just did the constants. And now I have a to the power 8 times a to the power 8. Well, that's the first law. So it's a to the power 8 plus 8, which gives me 48 times a to the power 16. Okay. So quite a few steps to go through there, but if you do it systematically and then try to apply each of the laws one step at a time, you'll be able to do it. So the tricky part about this one was this, because it really doesn't talk about it in the text, right? But if you think about something like 2 times 3, and then we square that, okay? Well, what that really means is 2 squared times 3 squared. Okay, and that's really all I did for this first bracket here. I had 2a squared to the power 4. What it really means is 2 to the power 4, and then times a to the power 2 times 4, which turns out to be a to the power 8. Okay. Now, the nice thing about working through these examples is that they have a solution right there. The support questions also have the solutions in the back of the unit, so you can always work through those. And again, work through a few of them until you're comfortable doing them. don't do the ones that you look at and go, ah, that's easy. Do the ones you look at and go, wow, that's scaring me. Like example 6C, that's kind of scary. But give that one a try. It'll test whether or not you really got it or not. Okay. And especially if they have a solution right there, you can kind of follow through and follow it along and see how closely you match their solution. Okay. And I think the support questions for, or sorry, the key question 4 is, I think it's relatively short this time, but just a lot of exponent laws, so something to look at. Okay, let's just keep moving on here. Whoop. Okay, yeah. So for the support questions, I guess they've given you all the support questions all at once. Rather than kind of after each topic. So, anything to the power 0 should be 1, right? I'm not really sure. Evaluate, I guess, means turn it into a number. 25. Now, if you get something like this, I would just leave it like that. Don't, yeah, for something like 1 over 81, don't try to write it out as a decimal. You're wasting your time. Same as this, 6 to the power 3. Okay, so you get the idea, right? That's what all I'm expecting to see there. Okay. Now, simplify. This is where they want you to turn it into a base with an exponent, a positive exponent. Okay, so if it ends up negative, you'll just have to take the reciprocal of it. Okay, and that's it. And then, as you can see, your key questions are fairly short. One of the good things to do after a lesson is if you look at the key questions for that lesson, and if you see anything that really stands out that maybe you're going to need some help with, you can mention it to me either straight away or at the beginning of the next class so I can take it up and sort of give you some hints. Okay. I better wrap it up here because the next class will be coming in. So thanks for joining us today. And remember, we have tomorrow, and then there's no class on Monday because it's Family Day, so you'll have a long weekend. All right, so we'll pick this back up tomorrow. Thanks for joining us.